So what do we actually do with this? So this is something in the finite element class that I carefully told you to ignore before. So this is this guy, which defaults to 0. So this is the entity nodes. Why is it the entity nodes? It's the entity nodes because it tells you which nodes are on each entity. And what it looks like is a dictionary of dictionaries, each one containing a list. So the outer dictionary numbers dimension. So these are the vertices, the edges, and the faces. Obviously, in 1D, we stop here. And then these are the entities within that dimension. So 0, 0 entity is local vertex 0, local vertex 1, 2, local edge 0, 1, 2, and the only local cell. And then each of these contains a list, and it's the list of local nodes which live on that cell. So that's the guy you've got to construct. A little bit more complicated than some of the data structures we've constructed so far. I won't play this now, but on the page there is a YouTube video that I constructed which shows you how this construction works. It goes through the construction I just described. So this is how to do it. So you're going to extend the init method of Lagrange element. So we just looked at finite element, and we discovered that finite element expects to be given entity nodes. And we use finite element as a practical matter through Lagrange element. And Lagrange element knows what its nodes are. So in the Lagrange element constructor, you can build the correct entity node dictionary and pass it through when it calls the super constructor so that it gets shoved into the finite element in the right way. And when you have done that, your Pavlovian reaction to another set of test passes will trigger and you'll be happy. So this is the tests that will do that. There are a couple of ways of doing this. There's at least 3. So you can work out in discrete maths what the right formula is for which nodes go on which vertices. That's one way of doing it. You can go back and re-implement Lagrange points so that Lagrange points comes out in entity order. That's how the Phoenix project do it, for example. So you could do it that way. Or you can do it geometrically, and to make your life easier, if you choose to do it geometrically, there is a point in entity class on the reference cell. So you can ask the reference cell if a particular geometric point is on a particular entity. And so you can do it via a looping mechanism that way and do it geometrically. So that is that. I think I will not talk about global numbering today. I will skip that to tomorrow because global numbering is officially the hard bit. So the good news is we've nearly got to the hardest thing in the course, which is global numbering for almost everyone. Once we've done that, it's a nice downhill ski to the end of term. So I will let you get on with this and run